Hello and welcome to SGN Tech Forum. Today I'm going to show you how to work with MATLAB and physical devices. MATLAB, as you know, it is a very popular simulation software with extensive library and always used in academia and industry. However, in this video, I'm going to show you a simple way to get started with MATLAB and hardware like Raspberry Pi, software dongles, and so on, because physical AI is going to be the next big thing. And MATLAB happened to have the largest library or extensive library for the same. So let's get started. So as you can see, MATLAB is a licensed software. However, it provides you a 30-day free trial with any email accounts, any public email like Gmail, and then you can access MATLAB, Simulink, and 80 plus products that are part of the MATLAB license and use it. So I'm going to show you a trial version because I don't have the license. And there are two flavors of MATLAB. First is MATLAB Online. That means if you want to do a simulation where there is no physical devices are involved as such, everything is virtual, then obviously simulation is a way to go. But MATLAB also give you a desktop software that you can install on your machine, and then you can plug in your hardware so that the MATLAB software and the hardware, they can talk to each other because they are essentially connected to and running on the same machine. So use your email, sign up for a MATLAB account. It gives you a 30-day free trial where you can use all the libraries. I already have the trial going on, and I'm recording this on the very last day of my trial. Here you can see it's MATLAB trial in use, and I have just this is the last day essentially. And you can see we have online training available, Simulink on-ramp and machine learning on-ramp. These are like a good training. I recommend you to attend whichever is applicable for you. And then you have two tabs, Open MATLAB Online and Install MATLAB. So let's click on Open MATLAB Online. And this is going to take you to the MATLAB editor, but this is essentially the online version. That means it is not running on my laptop or on my PC, but it is an online version. You can do pretty much everything what you can do at the local MATLAB. So why we are putting so much emphasis on local install? The reason being, we want to connect physical hardware, right? And what is the physical hardware that I'm going to run here? Let me show you. So I'm going to run this RTL-SDR dongle. And this is essentially a software-defined radio that you can tune to listen to a sub-GHz frequency, and then you can draw a plot on MATLAB using MATLAB software. So this is RTL-SDR, and let me show you Amazon snippet of this. This is R86 tuner. So this is essentially I'm running RTL-SDR version 3. It has R860 tuner and RTL2832. That is a modular. And of course, you need to connect the antenna. So you need this monopole antenna so that it can capture the frequencies. All right. So now what we are going to do, we are going to install the MATLAB locally. And for our purposes, I have this MATLAB installed already. And this is the local install. So this is our MATLAB R2025A version. This is I'm running here. And it says that your license will expire in 1 day. This is the editor space, essentially where you are going to write your program. And then here you have the add-ons. So let's first look at the add-ons. I'm going to say explore add-ons, and it is showing me all the add-ons available by category and so on. This is hardware support package, as you can see. And essentially we need these add-ons once we want to connect your physical devices, right? So for this, we are going to search for RTL, and you can see we have this communication toolbox support package for RTL SDR radio available, and this is already installed, right? So depend on what hardware you are attaching, go ahead and download the add-on from the ribbon here, add-ons, and explore add-on. You can manage add-ons. All right. So now it is right time for me to go ahead and connect this to my PC. And remember, this need a PoE. So connect it to your PoE port, a USB that can supply power. So let me go ahead and connect this so that we can run our programs. All right. Also, one thing you need to remember, once you connect your hardware, make sure the right driver is installed. So for that, you can see we have our ZA-DIG or ZA-DIG. This is the USB driver installation software. So it will automatically detect what driver you are running and what driver you will need. And then you can install that right driver here using this software. With that, let's go back to our MATLAB software. So SDR dongle is now connected to the PC, and we are running MATLAB R2025 version A on our PC. And also at the same time, I have installed the right driver for the SDR dongle using ZADR. All right, now time to check. At this point of time, you're ready to write a new script so that you can take some actions on the physically connected devices. In our case, I'm going to write a program that will program this SDR dongle to listen to on a certain frequency, and I'll make sure that I have something, maybe a Arduino device or another sensors that are producing or that are broadcasting on those frequency. So ideally, SDR is going to be a receiver, and we have senders in our environment. So let's write our first program. What you can do, you can either go to new script and write a program, or you can use new live script. You can also go to new, and we have these things available here: script, live script, functions, etc. You can open a program if you happen to have one already, and so on. This is our editor window. This is our workspace. And here you can collapse the workspace. You can search for things within the workspace and so on. Let me go ahead and say open. And we have this .m, detect and visualize LoRa packet. So this is an existing program. And since this is a script with MATLAB, hence it is ending in .m. So let me go ahead, double click and load this in our editor workspace. You can see this is essentially our program looks like. Detect and visualize LoRa packet. We have this clear all, close all, and CLC so that you have a clean works editor space. And then here the actual program starts. So what I'm saying that listen on a LoRa central frequency, which is a sub-GHz frequency 903.9 megahertz, and I'm defining some parameter like LoRa spreading factor is 7, bandwidth is 125 kilohertz, and CR, that is coding rate is for 1 by 5. All right. So this is this very simple program. We are staging our SDR dongle to listen on those frequency. If there is enough interest, I can go ahead and upload this on my GitHub repo so that you can download and work with this program. Once you have the program written, what you can do, you can simply go to run and click on run. However, there are other things. You can define a runtime, select a breakpoint, and so on. I have ran this program before, so I'm feeling confident. I'm going to go ahead and say run, and this will run the program. Here you can see the output. Attempting to connect to a RTL-SDR. Let me show you that before we go back and look at the actual capture. Attempting to connect to RTL-SDR, start continuous monitoring at this frequency. Found RTL-SDR with radio address 0. So that means this software, MATLAB software, was able to find the RTL-SDR that is physically connected to my PC, as we have mentioned in the program. Once SDR is connected successfully, then it is starting to do whatever you want it to do, right? And we wanted to just listen on that frequency and plot and save that, whatever it has captured. On the left side, you can see this is a workspace, and we have all the variables automatically. It got created automatically. So what is our LoRa bandwidth? What is our center frequency, CR, whatever I have defined here in the program, those are listed here. All right. You may have noticed something popped up, and because we were running visualize and save, and this is our spectrum analyzer. This is point in time how it looked. So there may be something going on for 903.9 megahertz. I have these door sensors. They send these things to 903.9, but you need to run it continuous enough to find something meaningful here. We have ran it only for 10 seconds or less. So that's why. But however, you got the idea. This is going to look like this. You can also change things here, like what is the channel selector. If there are multiple channels, you can switch the channels. Spectrum, you can have two-sided spectrum. You can change the spectrum unit and so on. I'm going to close this here. And let's go back to our MATLAB program. Let's go back and try to write one more program or continuous. Yes, so we are not visualizing. We just want to run continuously. And yeah, same thing, found RTL, and it is continuous monitoring. So you can see it's monitoring until I press Control C in the command window. It's not going to stop. And now this is a good time for me to play with my door sensor so that it can generate packets here, right? And these things do frequency hopping, so we don't know whether it's going to switch to 903.9 or no. You can also write a program which listens to a broad range of frequency, say entire LoRa range 902 to 928. All right, but this is only one frequency. And as you can see, I'm creating some traffic here. And these are not like regular Ethernet or Wi-Fi. They are sub-GHz frequency, and time on time you can see the spikes. And those are essentially the frame payloads. So this was an interesting program. Let me go ahead and see. Press Control C, and SDR is released. Spectrum Analyzer is released as well. All right, what else I wanted to show you? I wanted to show you publish. Yes. So you can also publish your result directly using publish. So you can say, I want to publish my file configuration. I can go ahead and click publish. I can publish it as an HTML. I can publish it as PDF. You can also work with hyperlink, inline latex, and so on. So publish is very important feature if you're writing or using MATLAB for some writing some kind of like a research or report. Make use of this. This is all I wanted to show you. So go ahead and play with MATLAB for whatever research or next project you're doing. At the same time, you can make use of MATLAB online learning and learn the different tools, etc. as per your requirement. Thank you so much, and I'll see you in the next video.